One of the most striking features of the James Webb Space Telescope is the sunshield, probably because it's about the size of a tennis court. Now that's too big to be sent into space that way, so at launch it's in a folded-up configuration. When the James Webb Space Telescope reaches its destination 1 million miles from Earth, the sunshield is then deployed. Different contractors are working right now together on a mechanism or several mechanisms to control the sunshield's deployment. One of those is Northrop Grumman's Astro Aerospace here in Carpinteria, California. One of the lead project engineers here at Astro Aerospace is Larry Heinlein. Hey Larry, so what exactly are you guys working on here?
This is a mid-boom assembly for the James Webb Space Telescope.
So what exactly is mid-boom assembly?
So there's one base tube, and there's 5 deploying tubes. The 5 deploying tubes deploy out, and as they deploy out, they unfold the layers of the sunshield.
And you have separate tubes because?
Because during launch, it needs to stow within about 5 feet of length, and when it's fully deployed, it's about 25 feet. But on the end of that boom is a 5-foot-long spreader bar, which the sunshield layers are attached to.
Oh, okay. That puts the layers of the sunshield in position, right?
That's correct.
Okay. Kind of reminds me of an antenna of sorts.
Yes, it kind of looks like your old-fashioned deploying antenna.
So Larry, how do you make these tubes extend?
Well, inside the carbon graphite tubes is something that we call the stem deployer, and Tim Martinez will help explain that.
This is called a stem deployer, and this mounts to the bottom of the base tube, and this is what drives the assembly and pushes the tubes up. And the way it works is that it pushes this material called stem out, and the concept is like a tape measure, so when it's coming out it becomes round, but when it's around this spool that's inside, it's flat, and there's a motor that drives the whole thing out.
It doesn't feel very heavy, but it's strong?
Yeah, it's made out of a very thin sheet of corrosion-resistant steel, but that's what's great about it. It's really light, but it can push up 100 pounds, and then there's also a requirement to pull back, and so it can actually pull back 400 pounds.
And why would you even pull back?
Once the booms are completely deployed, it pulls back, and the tubes are connected to a cable which tensions the whole sunshield and separates the 5 membranes.
Thanks for joining us for another edition of Behind the Web.